This one's a little tricky. Look at that denominator on the right. It's a binomial. What are we going to do? Panic. No, I'm kidding. Let's not panic. Here's what we are going to do. We're going to find the least common denominator among 6 and x plus 5. And I'm going to do this one a little bit differently. So up to this point, we've talked about how to find the least common denominator just in more practical ways. And slide that over so you can't see the next one. I don't want to scare you. So even though if you're following along on paper, you know what it is. What we're going to do in this case is just come over here and start finding least common denominators in a different way. Instead of like, oh, let's pick the smallest number and count until we find it. We don't have numbers, we have variables, and they're represented in ways with addition here that really would be difficult for us to do that, okay? I mean, it's possible, but let's not go there. You could do x plus 5 and then 2 times x plus 5, and then 3 times x plus 5, and then 4 times x plus 5, and then 5 times x plus 5, and then 6 times x plus 5, and that would be your least common denominator. So what everything I just said that sounded confusing was the old method, but now the new method is list every factor you have. Make sure your head's in the way so people can't see it. List every factor you have, which would be 6, one factor, x plus 5, the other factor, and then that is your least common denominator. It sounds simple, it really is, but then we have some little tricks to it that'll pop up as we continue to go. So our least common denominator is 6 times x plus 5. So every denominator gets 6 times x plus 5. Okay? To turn a 6 into a 6 times x plus 5, we already had the 6. We needed an x plus 5. We already had a 5. Okay? I am so tempted to cancel those, it would work backwards. How do we turn this into this? Well, to turn an x plus 5 into a 6 times x plus 5, I needed a 6. I already had a 5. So over here, he points to both of them. Over here, we're going to have a 30. Let's bring this up. So 30 over 6 x plus 5. Hey, should we distribute the 6 times x and the 6 times 5? No, just don't. It's not worth it. Trust me. It's not wrong if you do. It's just not worth it if you do. 5x plus 25. Okay, let's keep going. We're going to keep going with this. And when we do that, we're going to add these numerators together. I'm going to drag this out a couple extra steps. So 5x plus 25 plus 30 over 6 and then x plus 5. Okay, if you want to go ahead and do this in your head, you can. You'd be like, oh, well, that's 55. Okay. Yeah, sure, fine. You're right. So 5x plus 55 over 6 and x plus 5. And then pretty much every time, really every time I get to the end, I ask myself, can I reduce this? And the best way to really answer that is by factoring. So we're going to take this out a few more steps. If you're running out of room, you can go sideways with this. But 5 factors out of that numerator, and it gives me that. And no, nothing cancels. Don't cancel those 5s. Just don't do it. But no, nothing cancels. Sometimes you'll get to this step and say, oh man, I can reduce such and such. Not this time. You can't. So this one took a little extra work, but the big idea was the fact that we had to find our least common denominator by listing our factors of our denominators over here on the side and saying, oh, well then my least common denominator is 6 times x plus 5, which is a little obvious. It won't always be that obvious. So let's do the same strategy here. And when we do, we'll switch to green, of course. Least common denominator is x, okay, and x plus 2. Now, if you're tempted to say, this is my least common denominator, then sure enough, you've got x plus 2 taken care of. Does x go into x plus 2? No, not necessarily. I can't say for sure that x goes into x plus 2 because I would be saying that it is okay to cancel those, and it's not, so don't do it. X and x plus 2 are two separate factors. My least common denominator is this. Now we're going to turn every fraction into that. X plus 2. X plus 2. Okay? From here, whoops, that one. From here to here, your denominator changed. What changed? Well, I already had an x, I keep my x, but I also needed to multiply by x plus 2, okay? But I already had a 4 in the numerator. Again, I already had a 4 in the numerator on this side as well. From here to here, what changed? Well, I already had an x plus 2. I needed to multiply by another x. So let's keep going. All right, 4x plus 8. I'm going to just do all this at once. You know, like the last one took like 3 or 4 steps? Not this time. Plus 4x, all divided by x and x plus 2. Okay, good to know. We'll keep driving. 4x and 4x makes 8x. 8x plus 8 over x and x plus 2. And then looking ahead, we could have jumped from here to the next step where we'd say, oh, I can factor an 8 out. And that gives me 4. I'm sorry, 4. I was thinking, if this was written differently, how would it look? If I had written this problem to where something reduces, then I would have a... Nah, never mind. Anyway, nothing cancels here. Nothing. You do need to get down to where you can at least identify that nothing cancels. Is this correct? Yes. Is this correct? Yes, but it looks nasty. So at least get this far. But if you get this far, then you are really able to identify if something cancels or not. And nothing cancels in this case.